Okay, so let's continue. We were doing, wait. Yes, we were doing about the energy level diagram of endothermic reaction. Okay, so the endothermic reaction is, let me show you again. Um, there will be reaction pathway. Now, this is endothermic reaction. I had given you an example, which is calcium carbonate. And there is a thermal breakdown of calcium carbonate that is giving you calcium oxide plus carbon dioxide. And um, you have to supply a lot of heat energy to break this compound. Okay, so the products will be having less energy, and the reactants, oh no, wait. The energy is being absorbed during the reaction, so the products will be having more energy here, and the reactants will be having less energy. In exothermic reactions, products are releasing their internal energy to the environment, so the products are less energetic. This is endothermic reaction. Because in exothermic, the product have less energy, but this is endothermic reaction, means the energy is being absorbed, so the products are having more energy, they are more energetic now. So the reaction is endothermic. So the reactant have less energy, so you have to make reactants here, CaCO3. Then you have to go up. In here, you have to make product. Means the products are more energetic now. You have to do like this. Here, this is the enthalpy or energy of the product. This is the energy of the reactant. This is the energy level diagram. And what is this portion? Again, this is the energy which is being absorbed. Delta H is positive. This portion is telling you about the energy chain, that this is the energy chain. This much energy is being absorbed. This is the diagram of endothermic reaction. Now move to one more thing. Standard enthalpy changes. Standard enthalpy changes. What is standard enthalpy changes? Basically, when there is enthalpy change on a standard condition, I mean, you have to perform a reaction by maintaining some reaction condition, the standard reaction condition. So the change is called standard enthalpy change. For example, there is CH4 that is reacting with the oxygen gas, and that is giving you carbon dioxide, water, and large amount of heat energy, and that will be negative. Why it will be negative? Because this is a combustion reaction. The reaction is exothermic. So when, let me balance the equation, there will be 2 and 1, 2. There will be 2. Yes, this is balanced now. See, so what happened here? 1 mole of methane react with 2 mole of oxygen gas to form 1 mole of carbon dioxide gas. These are the gases. Methane is a gas, oxygen is also a gas. So when 1 mole of methane gas is reacting with 2 mole of oxygen gas, that is forming, or that is giving you 1 mole of carbon dioxide gas molecule and 2 moles of water liquid. So the enthalpy change here is called standard enthalpy change. But ऐसे नहीं कह देना. We have to tell them that we have maintained some reaction condition. There are 3 conditions which you have to maintain. Then the energy change will be standard enthalpy change. First, you have to maintain the pressure. The pressure should be normal atmospheric pressure. The pressure should be normal atmospheric pressure. Means when you have to check the enthalpy change of the reaction, means when you have to check either the reaction is exothermic or endothermic, or if the reaction is exothermic, so how much extra energy is being released into the environment. When, I mean, you have, for example, if the energy change is, for example, 32 and my answer is 31, so there is a difference. That difference should not be there. The enthalpy change has fixed value. So whenever you are working on the enthalpy change, you have to perform the reaction at a standard or at normal atmospheric pressure. You have to maintain a pressure which is atmospheric pressure. Means you don't have to pressurize the reactants. The reaction is exothermic and the products are trying to release energy and you are pressurizing them. They will absorb their energy again and you will say, Miss, the reaction is endothermic. The whole reaction will mess up. So whenever you are working with the enthalpy changes, you have to maintain the pressure. You have to maintain the pressure. What pressure should be there? Normal atmospheric pressure, which is equal to 1 atm. Okay. The next one, um, the next condition which you have to maintain, the temperature. You have to maintain temperature during the reaction. Mostly we are doing, we are performing reaction at room temperature. अब students कहते हैं miss, in winter the room temperature could be 2 degree and 3 degree. In summer season the temperature could be 45 degrees Celsius. The room temperature could be changed. So we have one standard room temperature, and that is 25 degrees Celsius. This is considered standard room temperature. So whenever you are working with the chemicals, to check the enthalpy change, you have to perform reaction at your room temperature, which should be equal to 25 degrees Celsius. And you should know the Kelvin value also. How can you convert degrees Celsius into the Kelvin? By adding 273. For example, if I say 3 degrees Celsius, just add 273, you will get your answer in Kelvin. So this is 25 degrees Celsius. You can add 273 into 25, you will get 298 Kelvin. So it means you have to maintain your temperature, which is 25 degrees Celsius or 298 Kelvin. You can perform your reaction at this temperature if you want to check the standard enthalpy change. The third one, we have discussed two conditions, and there is one more condition, and that is most important. Each substance which is involved in a reaction, means each reactant which is involved in a reaction, that should be in its normal physical state. Normal physical state. Normal physical state. I mean, if water is ice, so ice is not abnormal. That is also normal. If water is there in the form of a steam, so steam is normal thing, not abnormal. So what is normal physical state? The state of the given thing at room temperature. If you are using water in your reaction to check the enthalpy change, only. If you are using water in your reaction to check the enthalpy change, you have to use water at liquid form because water is liquid at room temperature. If you are using oxygen during any reaction for a standard enthalpy change working, something like that, so you have to use oxygen in a gaseous form. You don't have to liquefy oxygen to speed up reaction, to speed down reaction. No, we are not working on the speed of reaction. We have to check enthalpy change. Each bond will release energy. Each molecule will release energy, or each molecule will absorb energy. So you have to use normal atmospheric pressure, which is the standard pressure. You have to maintain your room temperature up to 25 degrees Celsius, and you have to use each reactant in its normal physical state, the physical state at room temperature. If you're using oxygen, that should be gas. You don't have to use liquid oxygen when you have to check the enthalpy change. These are three standard conditions when you have to find the enthalpy change. We have variety of enthalpy changes. Okay, variety of enthalpy changes. Enthalpy change of formation. This is very easy. You can learn only one definition, everything will be easy. We have variety of enthalpy changes. Okay. Number one, enthalpy change of formation. Enthalpy change of combustion. Enthalpy change of neutralization. Enthalpy change of atomization. This term is new to you, I guess. Enthalpy change of atomization. And fifth one is enthalpy change of hydration. Six, one, two, three, four, five, six, seven. Enthalpy change of formation, combustion, neutralization, atomization, hydration, solution. We have different type of enthalpy changes. Depends on the nature of reaction, now which type of reaction you are doing. If you are doing neutralization reaction, for example, if you are working with the neutralization reaction, so the enthalpy changes, enthalpy of neutralization, the enthalpy change of combustion, the enthalpy change of formation. Let me tell you the definition. Let's focus on this formation. Enthalpy change of formation or standard enthalpy change of formation. What is this? This is enthalpy change, simple. This is simple, delta H, the enthalpy change. The enthalpy change of formation means this is the enthalpy change when 1 mole of compound is formed. When you're forming something, when 1 mole of compound formed from its elements under standard condition. Let me give you the example. For example, let's make any compound. Hydrogen that is reacting with sulfur, and that is giving you H2S. Okay. Oh, wait, let's make it here. Yes. What is happening here? There is hydrogen and there is sulfur, and you are getting one compound, H2S. Hydrogen and sulfur both are joining together to give you H2S. There will be enthalpy change, definitely, bond breaking, bond making. Then there will be extra heat, which there is a possibility that extra heat is being absorbed or extra heat is being released. So there will be some delta H that could be negative and that could be positive. This is enthalpy change. This enthalpy change, which could be positive or which could be negative, it depends if the reaction is exothermic or endothermic. So this energy change in this case is called standard enthalpy change of formation. This is enthalpy change of reaction, enthalpy change of formation. Why? Because you are forming a compound. Let me tell you, the standard enthalpy change of formation, there is a difference in name only. This is enthalpy change, simple. This is enthalpy change. But in the reaction, we are forming new thing. We are forming a compound. So this enthalpy change is called enthalpy change of formation, because this is involved in the formation of compound. So the enthalpy change of formation is the enthalpy change when 1 mole of the product, okay, when 1 mole of compound is formed from its element or from its reactants, you can say, under the standard condition. You have to follow the standard condition, means the pressure should be atmospheric pressure, the temperature should be room temperature, and hydrogen should be there in a gaseous form. You know, hydrogen is gas at room temperature. The sulfur should be there in a solid form, because you know the sulfur is solid at room temperature. Now the energy change is called, now the enthalpy change is called enthalpy change of formation. Why? Because it is forming, it is involved in the formation of the compound. There is a difference in name only. What is enthalpy change of formation? The enthalpy change of formation, or the standard enthalpy change of formation, is the enthalpy change when 1 mole of compound, is formed from its reactant under standard condition. Keep in your mind, 1 mole of product is formed. You have to form 1 mole of the product. You can see the reaction is already balanced and we are getting 1 mole of product. For example, iron that is reacting with the oxygen gas, and that is giving you Fe2O3. If you try to balance the equation, so it will be 2 and 3. You have to write 2 here, you have to write 3 here, you have to write 4 here. If I follow this reaction, I mean, this is solid at room temperature, this is gas, we have maintaining the pressure and temperature, everything. But see, if I follow this equation or this mold, you see I'm getting 2 moles of the product. So the energy change is not the standard enthalpy change of formation, because the standard enthalpy change of formation is the enthalpy change when 1 mole of compound is formed. So you have to make 1 mole of Fe2O3. How can you make 1 mole of Fe2O3? I have to make only 1 mole of Fe2O3. 4 mole is giving you 2 mole. So 1 mole, what is the half of 4? Half of 4 is 2. You have to take 2 iron. 3 oxygen. What is half of 3? 1.5. You have to use 1.5 oxygen. You will get this. And now the energy change. Now whatever the energy change which is involved during this reaction, either positive or negative, that is called a standard enthalpy change of reaction. Is it clear? Yes, Sabur, any confusion?
No, miss.
Okay, Ifa, do you have any confusion?
Yes, so Miss, basically, if any reaction is formed to make it in the standard position, we have to make sure that only 1 mole is being formed.
Exactly. Only 1 mole should be formed.
Okay.
If there are more than 1 mole, you can see, I just corrected the equation. I just corrected the equation. Okay, so that's what you have to do. For example, basically all other reactions are same. There is issue with this reaction only. I mean, you have to change the number of moles here, and this is included in your past paper also. But let me tell you again, the enthalpy change of formation, we just discussed enthalpy change of formation, that could be positive, that could be negative also. It depends. It could be, there are few enthalpy changes which will be negative only. There are few enthalpy changes which will be positive only. That's what you have to learn. The concept is easy, the definition is easy, but see, the standard heat of formation could be negative, the standard heat of formation could be positive. It depends. Like when you are making iron oxide, the standard heat of, I mean, the standard enthalpy change will be positive, but there is one more reaction, carbon, the graphite. When it react with the sulfur, it gives you CS2. If you balance it, there will be 2. You can see we are getting only 1 mole. In this case, the standard, no, wait. When you form iron oxide, we just did this one, 1.5 oxygen, and we are using 2 moles of iron, and we are getting iron oxide. So the enthalpy change of formation will be negative here. It will not be positive. It will be negative. Oxygen help in burning. When iron is reacting with the oxygen, so it is burning with the oxygen. It will release energy, negative. But when you are reacting carbon with the sulfur, it is giving you carbon sulfide. Here, the heat of formation will be positive. So enthalpy change of formation could be positive, it could be negative. It depends. There is one more thing, which is standard enthalpy change of combustion. Standard enthalpy change of combustion. This is the symbol. And for heat, for standard enthalpy change of formation, this is the symbol. Okay, so standard enthalpy change of combustion. This is very simple. When 1 mole of substance is burned in excess of oxygen under standard condition, the energy change or the enthalpy change is called enthalpy change of combustion. This is so simple. Let me give you the example. For example, CH4 that is reacting with oxygen gas. But again, in formation, in this standard enthalpy change of formation, you have to make 1 mole of product. Here you have to burn 1 mole of reactant. I mean, you have to burn 1 mole of hydrocarbon or 1 mole of substance. CH4 will burn here. Na? So you have to take CH4 1 mole. So there will be carbon dioxide and water, and you will get some energy change. If you balance the equation, you will get 2 here, 1, 4, to here. So yes, we have 1 mole of substance. Okay, so what is standard enthalpy change of combustion? This is the enthalpy change when 1 mole of substance is burned in excess of oxygen under standard condition. Number 1 mole of substance should be burned. Number 2, oxygen should be excess. Reason, agar oxygen ki deficiency hogi, you will get incomplete combustion. Everyone knows there are 2 types of combustion, complete combustion and incomplete combustion. Incomplete combustion can be there when there is something like less oxygen. You will get carbon monoxide. वो combustion reaction ही नहीं होता proper. You will not get extra amount of heat energy. When there is proper combustion, the complete combustion, for that you require excess of oxygen, then you will get a proper amount of heat energy. So what is standard enthalpy change of combustion? The standard enthalpy change of combustion is the enthalpy change again when 1 mole of substance is burned in excess of oxygen so that you could get proper amount of energy. Okay, under standard condition, we have to maintain those 3 standard conditions. What does it mean? You have to maintain the pressure, you have to maintain the temperature, and you have to use the reactants in their normal physical state. Means CH4 should be gaseous, and during the reaction, you have to use gaseous oxygen. One thing more, we just discussed that standard enthalpy change of formation could be positive, it could be negative. Okay, but standard enthalpy change of combustion will be negative all the time because all the combustion reactions are exothermic. The formation reaction could be exothermic or endothermic, both. It depends. Like iron was burning with oxygen, so that formation reaction was negative. But all the combustion reactions are exothermic now. So enthalpy change of combustion reaction will be negative. It will never be positive. And this could be your past paper question. Keep in your mind, the enthalpy change of combustion will always be negative because all the combustion reactions are exothermic. It will never be positive. Let's discuss one more. For example, there is one standard enthalpy change of neutralization. Standard enthalpy change of neutralization. This is so simple. Let's write some neutralization reaction first. HCl plus NaOH. I told you whenever acid is involved, the reaction could be exothermic. Yes. Standard enthalpy change of neutralization. The symbol is this, HN. Okay, so the standard enthalpy change of neutralization is the enthalpy change when 1 mole of water, is formed by the reaction of acid and alkali. The moles of acid and the moles of alkali means the mole of acid or the moles of base could be changed. There could be 2 mole of acid, there could be 12 mole of base, but there should be 1 mole of water. So what is a standard enthalpy change of neutralization? When 1 mole of water is produced and when 1 mole of water is formed by the reaction of an acid and a base or an alkali under standard condition, the enthalpy change is called enthalpy change of neutralization. This is standard enthalpy change of neutralization is the enthalpy change, is the energy change when 1 mole of water is formed by the reaction of acid and the base. The number of moles of acid and the base could be changed. I mean, there is a possibility that you can use 6 mole of acid, you could use 1000 mole of the base, but there should be 1 mole of water at the product site. The energy change is called standard enthalpy change of neutralization. And it is mostly negative. I mean, the enthalpy change of formation could be positive or negative. The enthalpy change of combustion will always be negative, but the enthalpy change of neutralization is mostly negative. You can say 99% it is negative, but there is a possibility. Sometimes it could be positive. There could be any case. For example, let's suppose we are using very weak acid and the weak base. So there is a possibility of positive value of the enthalpy change, but mostly it is negative. And see, 1 mole of water should be formed by the reaction of acid and the base. I guess this is enough for today. You just have to learn only these 3. In next class, we have to discuss 3 more, and they are a little more difficult. They are similar to each other also. For example, we have to discuss the standard enthalpy change of solution and standard enthalpy change of atomization. That this term is new for you, and we have to discuss the detail of this thing. And the reaction is also new to you. The third one is standard enthalpy change of hydration. We have to discuss these 3 in upcoming class, and we have to continue the chapter. What else? We have to discuss the Hess's law. Hess's law. This is little difficult. This is a little difficult. The Hess's law. This is, you can say, we have to discuss that. We have to discuss the roots of energy changes in Hess's law. This is little tricky. I think then we have to do some calculation here. Then we have to discuss the Born energy, and that's it. The calculation is little tricky in this chapter. The Hess's law is not that much difficult, but yes, these 3 enthalpy changes are little difficult or little complicated, you can say. So this is for today. Inshallah, see you in the next class. We could cover the whole chapter in upcoming class. So see you in the next class, inshallah. Take care and Hafiz.